Hey guys, my name is Angel Morgan and I will be teaching you guys arithmetic and geometric sequences. The recursive version of an arithmetic sequence is an equals an minus 1 plus d, d being your common difference. The explicit version of an arithmetic sequence is an equals a1 times t times a1 plus n minus 1. A recursive sequence defines a term using the term before it, as represented here with the n minus 1, whereas the explicit version defines a term using the first term in a sequence. And for geometric sequences, the recursive formula is an equals an minus 1 times r, r being your common ratio, which is multiplying from the previous term. Your explicit geometric sequence is an equals a1 times r to the power of n minus 1. N minus 1, thinking of that as your term, your previous term, like this whole thing, because if n is your term, n minus 1 is just the previous term. So here are two examples of both arithmetic, recursive, and explicit equations. In our first example, we have the terms 2, 8, 14, 20, and 26. 2 being our first term, 8 being our second, third, fourth, and fifth. And we can see how each one of these numbers share the same common difference of plus 6. So 2 plus 6 is 8, 8 plus 6 is 14, 14 plus 6 is 20, so on and so forth. So to apply this to a recursive equation where we need to know our previous term, let's say we don't know our sixth term, we plug in, so our recursive equation is an equals an minus 1 plus d. We know our common difference. We don't know our an, so that's what we're finding. If we're finding 6, but we know the previous term, we could plug in 6 for n. So we have a of 6 minus 1 plus what our common difference is. And then a of 6, we know that a 6 minus 1 is 5. So this is just the fifth term, and if we come back here, we know what the fifth term is. The fifth term is just 26. We plug 26 in, and then we get 34 as our a of n. So for our second example, we're going to be utilizing our explicit formula. To remind you guys, the explicit formula is an equals a1 plus n minus 1 times our common difference. So if we want to find, let's say, the 8th term, we don't know what the 8th term is, and we can't utilize the recursive equation because we don't know the 7th term. So what we can do is take our first term, which is 50, plus our desired term, so we want 8, minus 1, times our common difference, where we can see it's negative 5. So if we just solve this, this is 7 times negative 5, which is 35, and then drop the 50 here. And Niamh, what's 50 minus 35?
15.
Awesome. an would be 15. And now for geometric sequences, I have two examples, and in our first one, we have the terms 4, 8, 16, 32, where you can see the clear relationship between them is times 2, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. And to apply this information onto the geometric recursive sequence, we have an equals an minus 1 times our common ratio. So let's say we want to know the fifth term. We plug in 5 for n, so we have a 5 minus 1 times our common ratio, which is 2. 5 minus 1 is a 4 times 2. And if we look back to our terms, we already know what the fourth term is. So we have 32 times 2 equals 64. So we can say the fifth term is 64. And for our second example, we have 1,000, 500, 250, and 125, where the clear common ratio is times 1/2 each time. It's crucial in geometric sequences to only use multiplication and not division, but you can utilize fractions to represent your division or whenever your numbers are decreasing. So to apply this information to our explicit equation, remember, explicit is whenever we want to find a term, but we don't know the previous one. So in this case, we have 4 total terms, but we want to find 6, and we don't know 5. So we can't use the recursive equation. So if you remember, our explicit equation is an equals a1, which is our first term, times the common ratio to the power of n, our desired term, minus 1. So what we can do is plug in our first term, which is 1,000, multiply it by our common ratio, which is 1/2, to the power of our desired term, which is 6 minus 1. So we know that 6 minus 1 is 5. And if I just plug this into my calculator, you will get 31.25 as your sixth term. Thanks so much for watching. Stay tuned for some more I Am 1 videos.